All right, this lesson is about rational numbers and irrational numbers and how to tell the difference between the two. So first of all, understand this, that a rational number is any number that can be expressed as a ratio of two integers. So all repeating and terminating decimals are rational. So all repeating and terminating decimals can be written as a ratio, and that's a rational number. Basically, if I thought about rational numbers, it's really pretty much all the numbers you can think of, with the exception of the special ones. So rational numbers are 1, 2, 3, 2.5, 3.0, 7.81, 1.333 repeating. All those numbers are rational numbers. The reason why is you can write it as a fraction, or you can write it, all of them written as a fraction, period. So you can write any one of these numbers as some fraction. 3 is 3 over 1. 3.0 is 3.0 over 1. 1.3 repeating, that should be 4 over 3. All those numbers can be written as a simple fraction that's exactly the same as that number. That makes them rational. Notice that the first word to it deals with ratio, which essentially is a fraction. All right, so numbers that are not rational are irrational. So irrational numbers, just in short, irrational numbers are a bit different from that. One most famous one you probably think of is pi. You can't write that as a repeating or terminating decimal. It goes on from 3.14 and goes on forever. But truthfully, if you take a square root of any number that's not a perfect square, it's also irrational. So square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10, etc. All those numbers we say are irrational. All those numbers give you a decimal that doesn't repeat and doesn't terminate. Square root of 4 is rational. Square root of 9 is rational. Square root of 1 is rational. All that fit in the previous category. Because square root of 4, if you square root it, you get a whole number, you get 2. And square root of 9, you get a whole number, which is 3. And square root of 1, you get 1. So all those numbers give you a decimal, give you a number you can write as a fraction. Like if you square root of 4, you get 2. And 2 as a fraction is 2 over 1. So all those numbers are rational. Irrational numbers, again, is pi, and pretty much all the numbers that you square root, there's not a perfect square. That's basically what it is. So if I had to sum all that up, that's what it is. Again, by definition, a rational number is a number you can write as a repeating or terminating decimal. An irrational number is a number you can't write like that. You can't write as repeating or terminating decimal. So this backside asks you to decide whether or not these sums are rational or irrational. So if I added the square root of pi plus 18, well, that sum is going to be basically pi plus 18. And if you plug into your calculator, you still can have pi in the answer. It's not going to go away. So that sum is not rational. Because if you added that, you still have pi part of your answer. If you added these, square root of 25 plus 1.75, 1.75 is a rational number. It's just you've made 1.75 a fraction. That's probably something like 175 over 100. That's what it is, and that's what it is. So you can make that a fraction pretty easily. So that is indeed a rational number. Square root of 25 is also rational. So it's basically 5 plus 1.75, which is 6.75. Still a rational number. So if you add up two rational numbers, you still get a rational number. The square root of 3, though, if you try to add that to 5.5, you don't really have an easy number to write. You try to figure out the square root of 3. If you plug into your calculator the square root of 3, clearly the square root of 3 would be 1.7320580. It's not a rational number. This decimal doesn't repeat and it doesn't terminate. So since it doesn't repeat and it doesn't terminate, that's an irrational number. So again, that's square root of not a perfect square. So if you add that to another number, it's still irrational. It's still going to be irrational. All right, and if you gave you this one, square root of pi plus square root of 2. These are two irrational numbers. If you add them, you still get an irrational number. On the other side, we have products. And sometimes you can multiply irrational number times another irrational number and get a rational number. For example, square root of 2 is irrational, and so is square root of 50. This is irrational times irrational. That product, though, is the square root of 100, which is 10. So you can get a rational number if you multiply two irrational numbers together. So this is definitely rational. Square root of 64 and square root of 4. Well, square root of 64 is rational, because square root of 64 is 8. Square root of 4 is rational. That's 2. So it still gives you a rational number, which is 16. Same case, square root of 9 and square root of 49. Both of those numbers don't fit in the irrational category. But both of those numbers are perfect squares. So by square root of them, you get whole numbers. 3 plus 7. Oh, sorry, 3 times 7. You do 21. Whereas square root of 10 is not a perfect square. Neither is the square root of 8. So because of that, when you multiply those together, you may or may not get an irrational number. Square root of 10 times square root of 8 is square root of 80. The square root of 80 is not a perfect square, so it's still irrational. So that's pretty much what you need to know about rational, irrational numbers. Basically, if you want to find one, look to see if you got a square root of some number that's not a perfect square. So as long as it's not 1, 9, 4, 16, 25, 36, 49, all those numbers you know are perfect squares. If you have a square root over it, it's going to be irrational. And it's not just square root. You have a cube root of some number. The cube root, say 7, is also irrational. But there's a whole lot of irrational numbers. But just know, none of those numbers can be written as a repeating or terminating decimal. That's all I have. Good luck.